This is math trigonometry. The vectors u, v, and w are drawn below. Sketch the specified vector. So we have u plus w. So here we have u and here we have w. We don't know the component form of u or w or the ij form, but we can sketch them visually. So I do need to make a little bit bigger sketch. So u plus w, we have u there, and we have w there. Now there's the parallelogram method where you basically sketch u at the end of w and sketch w at the end of u and make a parallelogram. At the end of that parallelogram, starting at the beginning of u, it's not the best graph, this would be u plus w, arrow. So essentially what we've done is we've done u, and then at the end of u we did w, and then we ended up here, and that would be u plus w. Now for u minus w, u minus v, this next problem, u minus v, we would do a u vector and then we do a negative v vector. So doing a u vector would look like this, u, there's u, and now if v is to the right, looks like maybe twice as much as u. Here's u's length and v's length is about twice that. If we do v, this is positive v. Negative v would be going this other direction, the opposite direction, but the same length. So here we are at the end of u, and then we do a negative v, and we end up here. This would be u minus v. Now, another technique that can be used, and this is something that's not as obvious, like doing u and then minus v from there, but like the parallelogram law before, essentially, if I were to finish the parallelogram for u and v, that's u plus v. Starting at the end of v and going to the end of u, that's u minus v. This technique is, some books cover this technique, so the hard thing about it is when you're doing u minus v, you have to know that you start at the end of v, and then from there go to the start of u, the end of u. And this is basically the same vector as this one. I think it's a lot more clear if you're trying to do u minus v's, go the direction of u. I don't care where you start, it can be at the origin, whatever. But go u, and then go negative v. And then wherever you end, starting at the beginning of u, ending at the end of the negative v, here you have your u minus v. This is a way to graphically draw the sum and difference of vectors. Find the magnitudes of the horizontal and vertical components for the vector v with the given magnitude and given direction angle. Round to an appropriate number of significant digits. An appropriate number, I'm going to go to 1 decimal place because we're given 1 decimal place. So that's how many I would have be the appropriate number of significant digits. Now, we have the magnitude of the vector, so this is how long the vector is, and we have the angle of the vector. So we could actually sketch this vector. 111 degrees, about there. This is v. So we have 111 degrees, and we have the length of this vector being 107.7. We don't know if that's inches or feet or whatever, so you don't really know if this is the right length, but I'm calling that v, so it's the right length. So this is 111.2 degrees. What we want to find is the x component and the y component of this vector. Now, we know from formulas x equals r cosine theta and y equals r sine theta, where r represents the length. This was from, you first see this in polar coordinates where r is the magnitude, and then theta is the direction. That's exactly what we have. This is called the absolute value of v, the magnitude, but this is 107.7 is r. So we can just plug these straight into the formula and get the x and y components. So the horizontal component x would be 107.7 cosine of 111.2 degrees, and then we'd go to our calculator for that, and y would be 107.7 sine 111.2 degrees. Now going to one decimal place, go to your calculator and compute it, and you should get negative 38.9 and 100.4. So these are the horizontal and vertical components. And you could write the horizontal component. This depends on your book, the notation, but you could just say the horizontal component. Negative 38.9, and the vertical component 100.4. Let's see if this makes sense with our graph. So they're saying go left 38.9 and up 100. So left 38.9 and up 100, that's believable. Alright, so this is how you compute the horizontal and vertical components if you're given the magnitude and direction. It's simply the x equals r cosine theta and the y equals r sine theta. And because because of the degrees, make sure you are in degree mode when you use your calculator. Alright, this completes this problem. Find the magnitude and direction angle to the nearest tenth of the vector. Give the measure of the direction angle as an angle in the interval from 0 to 360 degrees. So we're given negative 12, 5. These are the horizontal and vertical components. So we can make a quick sketch. Negative 12 and 5. This is our little vector right here. And what we're trying to find is the angle, that would be this, theta, and the magnitude, the length. Okay, now if we were to just look at this triangle, this is 12, this is 5, Pythagorean theorem would give us, I'm going to call it magnitude v. Magnitude v is the square root of 5 squared plus 12 squared. And if you calculate that, you get 13. So the magnitude is 13. You might also recognize this as the very famous 5, 12, 13 triangle, right triangle. Now as far as the angle goes, we can find this angle. We can use our regular right triangle trigonometry to find alpha. And that alpha would be, I think tangent would make a good job, because I don't want to use the 13 in case there was a mistake here. I want to use the original information that was provided. So I could work out a tangent. Tangent alpha equals 5 over 12. And then in degree mode, alpha would end up being, from our calculator, 22.6 degrees. Now keep track, this is alpha right here. And we actually need the angle for this vector, the theta. That would just simply be 100, so theta is 180 degrees minus alpha, which is 157.4 degrees. Alright, so what we have done here is we've succeeded in finding the angle and the magnitude of this vector. So that's all there is to this problem. Find the component form for the vector v with the given magnitude and direction angle theta. So we have the magnitude is 106.7 and the direction angle theta is 302.3 degrees. So a quick sketch. 300 degrees would be around there, so we're looking at this vector. This right here is the vector v. Now they want the component form, so x should be positive and y should be negative. This is a visual. X is to the right for this vector, x is to the right and y is down. So you'd have to go right positive, down negative. So x is positive and y is negative to get to this location. So when we use our formulas to find x and y component form, this will be a nice check to make sure that it all works out as we expect. The form x equals r cosine theta gives us r is the magnitude, so 106.7. Cosine theta, theta is 302.3 degrees. And we calculate this on our calculator, and we get 57.0, and that is the x component. We wanted it to be positive. We got a nice positive number. Looks good so far. Y is r sine theta. So this would be 106.7 sine of 302.3 degrees. And our calculator would give us negative 90.2. Now make sure you don't use a degree symbol on these. These are components. These are distances. These are not angles. All right, so x equals 57.0 and y equals negative 90.2. Depending on the book that you're using, you might call this v sub x or v sub h or some other notation for the horizontal component. I'm not quite sure what your book is using. And then you might also have v sub y or v sub v for vertical. Just depends on your book, but this is how you find those components. Perform the indicated operation. Use the form a comma b for vectors. So we're given u and v, and we want to find u plus v. Now u plus v vectors, that's just 1 comma negative 4 plus negative 6 comma negative 5. When you have component form, like u and v are in, you add up the corresponding components. So you would get the vector, the x component would be 1 plus and the negative 6 from the v, comma, and negative 4 plus and negative 5. So this simplifies to the x component of negative 5 and the y component of negative 9. That's all there is to adding these in component form. Component form is very convenient for algebra with vectors, and that is why it is so popular. So we're given u equals, in component form, negative 5 comma negative 6, and the v vector is 8 comma negative 3, and we're asked to find u minus v. I don't know about you, but when I do subtraction in my head, I tend to make more mistakes than if I do addition. So the way I work u minus v in vectors is I actually work out u plus negative 1 times v. Now I can do an addition. The negative 1 will be distributed into the vector v. So this would look like the vector negative 5 comma negative 6, that's u, plus negative 1 times the vector v is 8 comma 3. And we distribute the negative 1 and we have negative 5 comma negative 6 plus vector negative 8 comma negative 3. Now we can do additions. Negative 5 plus negative 8 for the x component and negative 6 plus negative 3 for the y component. So we end up with negative 13 comma negative 9. Now I have all of the steps written down here. I don't do all the steps when I'm doing these on my own. I speed up some. But one thing I don't speed up is trying to do too many subtractions in my head. So I'd rather write down the distributing the negative and then do all this additions in my head. That would be fine. Okay, great. Given v in component form is 2 comma 6, find the vector 10v. Now 10v, scalar multiplication. All right, scalar multiplication. So 10v is just 10 times the vector 2 comma 6. And what happens is this 10 is simply distributed in. And we get the vector 10 times 2 comma 10 times 6, which simplifies to 20 comma 60. So essentially what has happened is our old vector 2 comma 6 and our new vector 20 comma 60 in standard position start at the origin. They're in the same direction, but the 20 comma 60 is 10 times. It's been scaled 10 times as long as it was before. That's why this is called scalar multiplication. It does not change the orientation or the angle of the vector, but it does change the length. So v is in component form 8 comma negative 2. And u vector is 9 comma negative 2. And we are to find 6v minus 6u. So this would be written 6 and then the vector 8 comma negative 2. And now I'm going to write plus and in parentheses negative 6 parentheses and the vector u is 9 comma negative 2. So we're going to, I didn't use vector brackets. The vector brackets are the greater than, less than brackets. We're going to distribute these scalars, the 6 into v and the negative 6 into u, and get these new vectors, 6 times 8, 48, comma 6 times negative 2, negative 12, plus the vector negative 6 times 9, negative 54, comma negative 6 times negative 2 is positive 12. Now we can just add these two vectors together. 48 plus negative 54 is negative 6. And negative 12 plus 12 is 0. And we end up with the answer negative 6 comma 0 in component form. So given u in component form is the vector negative 5 comma 5 and the vector v is 15 comma negative 8, we want to find u dot v. So this is not multiplication, this is a type, this is the dot product. So dot product. Now to compute the dot product, the basic rule is first times the first plus the second times the second plus dot dot dot, depending on how many components you have. These are two-dimensional, so that would be it. Sometimes you'll have three-dimensional or four-dimensional vectors. They have to be the same size vectors to do the dot product. So these are both two-dimensional vectors. So u dot v would be a number. When you're done with this dot product, you do not have a vector anymore. You have a number. Just a whole number, not a whole number, a real number. Might be whole. This one will be whole. So this one would be the first negative 5 times the first of v is 15 plus, and then the second of u is 5 times the second of v is negative 8. So we have negative 75 minus 40, and that is negative 115. This is not an angle, no degree signs. This is not a vector, so no component form or bold or whatever notation your book might be using. This is a number. The dot product of u and v is negative 115. Find the smallest positive angle between the given vectors to the nearest tenth of a degree. So the vectors are in component form, negative 3, comma negative 5, and negative 2, comma 6. Although a graph is not necessary, it is still nice to see what they're asking about. So negative 3, negative 5, we have a vector that points into the third quadrant. And negative 2, comma 6, we have a vector that points in the second quadrant. And we're looking for the angle in between. The smallest angle. So we have one angle that's less than 180 degrees. And we have another angle going the other direction, which would be larger. We want the smaller of those two. That's what they're asking for. And the definition of the dot product, u vector dotted with v vector, is the magnitude of u times the magnitude of v times the cosine of the angle between. From this formula, you can solve for cosine of the angle between and get u dotted with v divided by the magnitude of u times the magnitude of v. And we can find u dot v, and we can find the magnitude of u and v. And so we can compute the right side, and then we can do arc cosine and find the angle. So let's work out all the pieces. So u dotted with v would be -3 times -2. That's the first times the first, plus, always plus. The second times the second is -5 times 6. So that would be 6 minus 30 is -24. There's u dot v. The magnitude of u we need, that's the square root of the sum of the squares of u. So square root of -3 squared plus -5 squared. That's the square root of 9 plus 25, which is the square root of 34. And that does not simplify. Even if it does, since we're going to use our calculator with arc cosine, I probably wouldn't simplify that. Now the magnitude of v. It's the square root of the sum of the squares of v. So -2 squared plus 6 squared. We have the square root of 4 plus 36, which is the square root of 40. And although that reduces, I'm not going to do it. We can now set up cosine theta equals, the dot product is -24, divided by the two magnitudes. So we'd have the square root of 34 times the square root of 40. And I have a parenthesis around the denominator, so I can just type this whole thing into my calculator, and it'll give me an approximation. Although I'm not going to use the approximation for the next step, I will write it down so you can check your work. So we have -24 divided by parenthesis the square root of 34 times, and this is in parentheses so I can use times, square root of 40. Get -0.651-ish, -0.651-ish. Taking arc cosine, make sure you're in degree mode. Arc cosine of that number, so I'm going to do arc cosine answer on the calculator, gives me 130.6 degrees, and I have rounded, as requested, to the nearest tenth of a degree. And from our graph, that actually looks pretty close. It's more than 100, or at least more than 90. 130 is the answer. That's the smallest positive angle between these two vectors. Determine whether the vectors are parallel, perpendicular, or neither. We have the vector v in component form as 3, 2, and the vector w is 2, -3. Now there are two basic tools. We can use the dot product. The fact v dot w equals 0 if and only if v and w are perpendicular. And then we can also use cosine theta, the angle between the vectors, will be v dot w divided by the magnitude of v times the magnitude of w. So we can actually find the angle in between. If that angle is either 0 or 180, of course they're parallel. If that angle is 90 or 270, that means they're perpendicular. If that angle is anything else, neither. Now obviously the dot product, you need to do the dot product in order to work out the angle between. So it makes sense to do the dot product. And if it equals 0, you happen to be done because they're perpendicular. If it's not equal to 0, you would continue on and see if you can work out angle theta to see if that's 180 or 0 to find out if they are parallel. So let's work out the dot product. V dot w would be the first of v, 3, times the first of w, 2, plus the second of v, 2, times the second of w, -3, and we get 6 minus 6 is 0. These are perpendicular. be prepared that if this is non-zero, to continue forward finding the angle between. And then you will find out whether they're parallel if the right side, when is cosine parallel? When is cosine, see, the parallel angle would be 0 and cosine of 0 is 1. So if the right side ends up being 1, then you would have parallel. So you work out the right side, and if you get 1, they're parallel. If you get 0, and that happens when the dot product is 0, when is cosine 0? At 90 degrees. So that's perpendicular, as we have it. On this problem, we are to determine whether these vectors are parallel, perpendicular, or neither. We have the vector v in component form of 4, negative 1, and vector w, 8, negative 2. So let's begin by finding the dot product to find out if they are perpendicular. The dot product would be the first of v, 4, times the first of w, 8, plus the second of v, negative 1, times the second of w, negative 2. This is 32 plus 2, so we have 34. Now had that been 0, we'd know they're perpendicular. So what we know now is they're not perpendicular. We now need to work towards the formula cosine theta equals v dotted with w divided by the magnitude of v and the magnitude of w. This is the angle between them. If we can work out the right side to be equal to 1, then we know that cosine of an angle equals 1 when that angle equals 0 degrees. And if the angle between these two vectors is 0 degrees, they are parallel or equal. We can see these vectors aren't equal. So they would be parallel. So we have to work out the right side. We have the dot product already computed. It is 34. We need to work out the magnitudes. So that's next. The magnitude of v is the square root of the sum of the squares of v. So 4 squared plus negative 1 squared. That is 17, square root of 17. And the magnitude of w is the square root of the sum of its square. So we'd have 8 squared plus negative 2 squared. That's 64, and 4 is square root 68. So cosine theta equals the dot product, 34, divided by the two square roots, 117, and the square root of 68. Now we work out the right side. If this equals 1, they're parallel. If this doesn't equal 1, this is neither parallel nor perpendicular. So go to your calculator now and compute the right side, and you get 1. All right, so we have cosine theta equals 1. That implies theta equals 0 degrees. That implies these are parallel. If the smallest angle between two vectors is 0, they are parallel. Excellent. Write the vector as a linear combination of the unit vectors I and j. Essentially, this is to decompose this vector into horizontal and vertical components. So the vector a comma b can be rewritten as a times the vector 1 comma 0 plus b times the vector 0 comma 1. That is ai plus bj. So 6 comma negative 6 can be rewritten as 6i minus 6j, where I and j are the unit vectors. And that's all there is to this problem. You could also write this as 6i, where the 6 is the horizontal component, and plus parenthesis negative 6j if that's something that you would need to do. But it's basically the same problem. Very nice. Solve the problem. If a in component form is the vector 2 comma 1 and b is the vector negative 1 comma 2, find the magnitude and direction angle for negative 4a minus 3b. We need to find the magnitude and direction for negative 4a minus 3b. We'll first find the component form of negative 4a minus 3b. Component form is the easiest for this arithmetic on vectors. So we'll start off by getting negative 4a minus 3b, and this will be negative 4 times the vector 2 comma 1 plus parenthesis negative 3 times the vector negative 1 comma 2. We are now going to distribute the negative 4 into the A vector and the negative 3 into the B vector, and we get vector negative 8 comma negative 4 plus vector 3 comma negative 6. And those add up nicely. That is negative 5 comma negative 10. So this is negative 4a vector minus 3b vector in component form. Negative 5 comma negative 10. A quick graph. We're left 5 and down 10. So the angle we're looking for is more than 180 degrees, but less than 270 degrees. We'll get a reference angle from our calculator, and then it looks like we'll add 180 degrees to that. So let's start off with the magnitude. The magnitude of negative 4a minus 3b is just the square root of the sum of the squares of its vector. So that would be parentheses square root negative 5 squared plus negative 10 squared. That gives us 25 plus 100, so that is the square root of 125. And 125 is 5 times 25. We can square root the 25, and we end up with the magnitude as 5 square root 5 magnitude. So there's half of our answer. We also need to find the direction angle. And we can do that with tangent of theta equals y over x, where y is the second component and x is the horizontal component. So we get tangent theta equals negative 10 divided by negative 5, or 2. So theta is arctangent of 2. In degree mode, you get approximately 63.4 degrees. Now, back to the picture. What we have found is just the reference angle. We need to add 180 to that to get into our third quadrant. So the direction, we work out 180 degrees plus 63.4 degrees. And we get 243.4 degrees direction. Okay, we found the magnitude and direction of this angle, negative 4a minus 3b, this vector. Great. Question, find the magnitude of the resultant vector. And they provide us u in ij form is 9i plus j, and v is 5i plus j. Now, they don't tell us what to do with u and v, so this question is not a complete question. But I will answer some common questions. For example, let's find the magnitude of u. That's the square root of the sum of the squares, so that would be the square root of 9 squared plus 1 squared. Now, some people don't see the 1. That's because it's not there. How many j's are there? Well, there's the invisible 1j there. Same with v. V will have an invisible 1 for the j. It does, in fact. So the magnitude of u is the square root of 82. The magnitude of v, the square root of the sum of its squares, so that would be 5 squared plus 1 squared, 25 1, square root of 26. And if they mean and as addition, we could work out the magnitude of u vector plus v vector. First off, we'd have to find what is u plus v. The x components, 9 plus 5 is 14, and the y components, 1 plus 1 is 2. I guess I went to component form, magnitude 14i plus 2j. We could also stay in the ij form. Either way, we would have to square root the sum of the squares, 14 squared plus 2 squared. And that gives us the square root of 200. Now this is 2 times 100, so we can reduce that one to 10 square root 2. Now, depending on what they actually mean, and hopefully if you're taking a test, the question will be much more clear than this. You can find the magnitude of u, v, u dot v, not u dot v, sorry, u plus v, u minus v, 3u plus 5v, whatever they ask, you can do it. It's just the square root of the sum of the squares.